Okay, this one is going to be really quick. I got 3 examples. So solving inequalities, very similar to solving equations. Instead of an equal sign, you have an inequality sign, greater than or less than. It also could be greater than or equal to or less than or equal to. Remember, this bar under the inequality means equal to. So this one is greater than or equal to. Okay. First, just like equations, distribute. So this is a -3. -3 times 2 is -6. So I get -6x. -3 times -5 becomes positive 15. Plus 1 is greater than or equal to 4. Combine my like terms. -6x plus 16 is greater than or equal to 4. To solve for x, I first have to get rid of this 16. So I'm going to use the inverse operation. It's positive 16. I'm subtracting 16. -6x greater than or equal to, this becomes -12. Positive 4, -16, different signs, subtract the numbers, keep the sign of a larger number. This is where inequalities is different, because when I divide by -6, if you remember, something happens because that's a negative. What happens is that I need to change this inequality to a less than or equal to sign. It flips, it changes the inequality when you multiply or divide by a negative number. Okay, so then -12 divided by -6 becomes positive 2. So what that means is any x that is less than or equal to 2 will make this inequality true if you plug it in. Okay, so this one's similar to the equations that are question whether is it always true, sometimes true, or never true. Solve it the same way. So distribute the -2, -6x minus 2 is greater than -6x plus 7. I'm going to combine my x's together because they're on opposite sides of the inequality. Here's my inequality sign. I'm going to add 6x, and what happens is they cancel out here, and I'm left with -2 is greater than 7. I didn't change the inequality at any point because I didn't multiply or divide by a negative. Because this is not a true statement, -2 is not greater than 7, that means this inequality is never true. If it is a true statement, then it would be always true. For example, if it would have said -2 is less than 7, that is a true statement. That's when it would always be true. It's only always or never true if the variable cancels out. Okay, so if you still have a variable left, that's when it's sometimes true. So here's one. I'm distributing, again, 6 times 2x is going to be 12x. 6 times -1 becomes -6, greater than or equal to 3x plus 12. When I subtract 3x, because I've got to combine my like terms, 9x minus 6 is greater than or equal to 12. I move the x's to the left side. I'm going to add 6. 9x is greater than or equal to 18. Now I can divide by 2. Because the x's didn't cancel out, that means that this is sometimes true. And the times that this will be true is when x is greater than or equal to 9. So that's the sometimes. Alright, that's it today. Real quick. No joke for you today. We'll catch that next time.